Good morning. I hope everyone is doing well. So this morning we're going to talk about differentiation, and we're going to start. We're going to start with the differentiation from the first principle. But before we talk about differentiation, we need to understand what it means. So differentiation simply means is denoted as dy dx. So dy dx simply means that difference in y over difference in x. So differentiation talks about how the value of y changes whenever x changes. So dy dx simply means that the relation that it talks about the relation that both x and y they have. Whenever there is change in x, it also have a corresponding change in what y, so that they are related. You get it? So dy dx is read as the rate of change in y with respect to x, meaning that the rate at which the y value changes as the value of x also changes. I mean the effect that it will be on the y values whenever the x values changes. You get it? So in geometry, if you draw the graph of a function, dy dx gives the gradient of the curve at a particular point. So you see, in straight lines, we talk about gradient of a straight line. That's y2 minus y1 over x2 minus x1. That's the gradient of a straight line. The same thing happens here for a curve. When you draw a curve, if you want to find the gradient of that curve, it's the same as you differentiating that curve or that function. So difference in y over difference in x, the same as the gradient. But one thing you should know is that for a curve at each particular point, let's say P here, it has different gradients. Here to has different gradients. Here to has different gradients. Here to has different gradients. So at each point, the curve has a different gradient. It's not constant as compared with the straight line. For straight line, at each point when you find the gradient, you're going to have the same answer. So for straight lines, the gradient is constant, but for a curve, the gradient keep on changing at each point. You get what I'm saying? So that's the whole idea about differentiation. So differentiation simply means the gradient of a curve at a particular point. It's similar to the gradient of a straight line, just that for straight line the gradient is constant. Whenever you calculate for the gradient at each point, you're going to have the same gradient, but for a curve it changes, it varies. So now, without wasting my time, let's talk about differentiation from the first principle. So when we talk about differentiation from the first principle, we use this formula. So dy dx is equal to f of x plus h minus f of x over h. That's the formula that we use. So dy dx means we are differentiating a function y, but the effect will be on the x values. That's what it means. So f of x plus h minus f of x over h. That's the formula that we use. So for illustration, let's do this question. I have y is equal to 4x, and I want to differentiate it using the first principle. Another word that can be used is find the derivative. It's the same thing as differentiation, the same thing. Find the derivative of the function using the first principle. It's the same thing as differentiation from the first principle. I hope you get it. So I have a function which is y is equal to 4x. This is my formula. Before I begin, I have to find my f of s plus h. Now, f of s plus h simply means that if I come to the function that has been given to me, wherever I see x, I replace it with x plus h. Wherever I see x, I have to replace that value with what? X plus h. That's what it means. So f of x plus h is very, very simple. Whenever I see x in the function, I have to replace it by s plus h. So we are finding out f of s plus h. So f of s plus h is equal to 4. And then here's x. This x will be replaced by the whole x plus h here. I hope you get it. That's very, 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 very simple. You get it? Now the f of s is the same as the function has been given to you in the question. What you are being asked to differentiate. always know that that one is the same as the f of x. So the f of x here, you see I wrote 4x. So f of x here is the same as what the function that we are differentiating. How to get it? So let's use the formula. dy dx is equal to f of s plus h, which is what? This. So 4 bracket open s plus h minus f of s. F of s is the same as the function given to you. So the function is 4x, so minus 4x. Now let's expand the bracket. 4 times x will give you 4x. 4 times h will give you 4h minus f of x, which is what? 4x all over h. Now I can cancel. Can I cancel sometimes out? Yes. I have 4s here and negative 4s. So 4s minus 4s plus 4h all over h. Now 4s minus 4s will give you 0. So they will go away, leaving 4h over h. Now this h can cancel this h, leaving 4. So the dy dx using the first principle is very simple. It's 4. You get it? This is not difficult. It's very simple. Let's try our hands on another question. So our next question is, find the derivative of y is equal to 2x plus 4. So we want to find the derivative. Once again, this is the function. Please know that y is the same as f of x. Don't forget, y is the same as f of x. They're the same thing. So this is the function. So how do you differentiate using the first principle? So we know that the formula is dy dx is equal to f of x plus h minus f of x all over h. So f of x plus h simply means that when I go to the function, wherever I see x, I replace it with what? X plus h. So let's find out f of x plus h. So f of x plus h will be equal to, so if you check this function, it's 2 multiplying x. So the x will be replaced by what? X plus h. So you've seen 2 multiplying x plus h, then plus 4. So that's what? Our f of x plus h. Now let's substitute it into the formula. So dy dx becomes f of s plus h, which is this, plus the whole this, how we get it, minus f of x. F of x is the same as the function that has been given to you, like I said earlier on. So minus 2x plus 4. Please, our advice is that whenever you are writing the f of x, put them in brackets, okay? If you don't put them in brackets, you are going to have problems with your operating signs. So make sure that you put them in brackets. So bracket open 2x plus 4, which is all the f of x. Now let's expand the bracket. 2 times x will give you 2x. 2 times h will give you 2h plus 4 minus, now if you want to expand this bracket, there's invisible negative 1 here. So negative 1 times this will give you negative 2x. Negative 1 times 4 will give you negative 4. Now let's group like times. So we have 2x plus 2h plus 4 minus 2x minus 4. Now 2x minus 2x plus 4 minus 4 plus 4, 2h. Now this and this will cancel, they'll give you 0. This and this will cancel, they'll give you 0, leaving only 2h. So you have 2h over h. Now this h can cancel this h. Now dy dx is left with 2. Very simple. It's not difficult. It's very simple. All you need to do is to practice more. Now let's solve another question. This question says differentiate with respect to x of f of x is equal to 3x squared plus 2. So now let's differentiate it. Like I said, y is the same as f of x. Like I said, y is the same as f of x. So you can just say that y is equal to 3x squared plus 2, or f of x is equal to 3x squared plus 2. They're all the same. Okay, but in this question, let's use f of x so that you'll be familiar with that one too. So we are saying that f of x is equal to 3x squared plus 2. So now let's write our formula. You see here, because we are using f of x, we can't say dy dx. So another way to write dy dx is f prime of x. You see, f prime of x is the same thing as dy dx. Nothing has changed. The same formula, the same steps. Just like here, are they using f prime of x, which is the same as dy dx. So f prime of x is the same as what? The formula is f of x plus h minus f of x over h. F of x plus h minus f of x over h. So once again, let's find our f of x plus h. So this is the function. Whenever I see x, I replace it with x plus h. So I'm going to have 3 bracket open x plus h all squared, because the x was squared. So this x plus h, so I have to square everything, plus 2. So now let's expand. Now x plus h all squared can be written as x plus h multiplying x plus h, then plus 2. I hope you understand this step. So now let's expand. S times s will give you s squared. S times h will give you hx. H times s will give you hs. H times h will give you h squared. Then plus 2. Let's expand. Let's multiply this whole 3 with this whole expression with 3. So I'm going to have 3 times s squared. That will give you what? 3s squared. 3 times. Before that, please pay attention here. Here you have to group like terms. You see, you have s squared plus hs plus hs plus h squared. Now hs plus hs will give you 2hs. I hope you understand now. So now let's expand the bracket. 3 times s squared will give you 3s squared. 3 times 2hx will give you 6hs, because 3 times 2 will give you 6. Then 3 times h squared will give you 3h squared. Then plus 2. Okay. Now this is our expression for f of x plus h. So now that we have found f of x plus h, let's go ahead and use our formula to calculate for the f prime of x. So the formula is f of x plus h, which is the whole this, minus f of x. F of x is the same as the function, which is what? 3s squared plus 2. Please, I can always say that, put them in brackets. Okay. Now we're going to have 3s squared plus 6hs plus 3h squared plus 2. Now if you expand the bracket, we're going to have, there's minus 1 here. Minus 1 times 3s squared will give you minus 3s squared. Minus 1 times 2 will give you negative 2. So that's it. So we had 3s squared plus 6hs plus 3h squared plus 2 minus 3x squared minus 2. So let's group like terms. So we have 3s squared minus 3s squared, 6hs plus 3h squared plus 2 minus 2. So 3s squared minus 3s squared will give you 0. 2 minus 2 will give you 0. So we'll be left with this 6hx plus 3h squared all over h. Now you see there's something common here. The common term here is h. So I can factor that h out. If the h comes outside, we're going to have 6x plus 3h. Because here we are having 3h squared. So if that h, if you factor h, one of the h out, we're going to have 6x plus 3h all over h. But this h can cancel this h, leaving 6x plus 3h. Now when you get here, the question did not give us h. We introduce h into the expression. So you have to make sure that we get rid of the h. We make sure the h goes away. So how do you do that? We take lim as x approaches 0. So what it means that wherever we see h in the expression here, we replace it with 0. So every term that has h needs to be replaced by 0. We're going to have 6x plus 3 multiplying 0, because 3 has what is multiplying h. You get it? So wherever I see h, I replace with 0. So I'm going to have 3 times 0 is 0, right? So f prime of s becomes 6x. Please note that the f prime of s is the same as dy dx, so don't get confused.